Spider-Man is my favorite comic character, and since last year I have experimented with all the technique necessary for the animation of this character in 3D in Blender. It was when I wanted to learn how to simulate web that I realized that very few YouTube videos on the subject existed. So I took the time to test different ways to find the right workflow, and that's what we're going to see in this video. So, we are in Blender, let's go. We're gonna start by cleaning this app and removing the collection. Don't forget to save the project. For me, I'm gonna save it right there, and I'm gonna call it Web Tutorial 2, because I already done one, and it didn't work. Then I like to stay organized, so I will directly come to make my collection. The first one will be called Web Body. Second one I will call Constraint. And the third one I will call Environment. I color it because I like it, and you can do it too, it's a help sometimes. The process will be done around close simulation, and what I noticed after a lot of testing is that close simulation on web, for example sculpt or modeled, often have errors, are often not optimized, or have parts that are not joined together. The solution to this problem is simple. We will come to do a simulation on vertex only, and we will add thickness with modifier. So we'll start by adding a plane. I'll center on it. We'll go to edit mode and we'll do M merge at center. What's make that we have only one vertices left. I will switch to top view, or if you don't have the shortcut, you can click just here. At this point, we will start to build the shape of our web with extrude and direction. I will increase by 3, 1, 2, 3, and according to X. 1, 2, 3. No need to be very precise. This is not what we need. We will simplify the process to avoid modeling everything by hand. We will add a mirror modifier that we will duplicate and put it in Y, which now we need to model only a quarter of the web. Now the process is quite simple. We will reach the point between them with F. With Ctrl R, I will add a vertex that I will move to give it a rounded shape. So we will alternate between Ctrl R and F to make the shape of our web. I specify that if you want to extrude several vertex at the same time, for example there's 3, we do not extrude this with just E. It gives us a catastrophic result. So we will come to select only unconnected vertex and use the extrude along normal tool, which will extrude our vertex into the axis we need. Same things with the middle one, and keep in mind that if you extrude everything at the same time, it will make a face, and this is not what we want. I'll speed up to the next step. Here we find ourselves with this shape. The problem here is that we have a form that's far too linear and symmetrical. To correct this, first we will apply the mirror modifier. There is several methods. You can apply it from there, or with Ctrl A, it's a shortcut. Or you can go to Object, Convert into Mesh. It's a lot faster. And now we have all our points into one mesh. Now we will select one vertex out of 2 and scale them to give the web either a more rounded shape or a bit of a star pattern. But easy for you to choose. You can play with it. I go on a rounded shape to have an organic side. The next step is to break the symmetry of the web. So always with the same process is to add a line from where you want in the web as long as the vertex are connected. The only thing to avoid is to do this and leave it unconnected, because on the simulation is played, the vertex will hang in the void, and that's not what we want. If we want to connect 2 points, we make a Ctrl R, and to reach them here is an internal line, and we will make out our path and make follow the line to the web. I will join here, here, and here again, and here we have an additional line that breaks the complexity. I will do 4 or 5 of this You can go very far in the detail if you want, but it's not an obligation. That will just add more complexity and detail to your web. I'm going to speed up again so you don't get that boring part. We found ourselves with this shape again, and it's still very linear and regular for the moment because it is flat, but it's not a problem because once deformed, it will have an organic shape. Now we had the tail of our web. I extrude the vertex of the center in the z-axis, not necessarily too much, and added vertex between the tail and the center of the web. We then connect the vertex near the center with the vertex at the bottom of the tail. Always the same principle with F. Feel free to vary the height, put several on the same point. The goal is to have a maximum of irregularity and detail. And perfect. Maybe I'll get rid of this one because it's a stain, and I'll take it back here and here. And I want some more true here to support the shape. So we have our final shape that we're going to rename here. The next step is to assign the pin group. We will assign the entire endpoint of the web and the top of the tail. With Ctrl G, we create a new group of vertex. That we'll find here, we rename it, and we check if it's active. Then we need to add the hook. On each point of the group pin, we add a hook with Ctrl H, then hook to new object. Repeat for all the points, and don't forget the tail. We can do them all at the same time, or it will hang all the points on a single object, and that will penalize us in the future. The only one I'm going to change now is this one, and I'm going to rename it tail. Change shape and size. And now we're going to the simulation. I'm lowering the resolution to 3 or 4. I advise you to play with the simulation to double or triple your timeline, so I will put it to 500 and match it with the simulation cache. Very important not to forget the pin group that we created, because if I launch the simulation, we can see that the web fall into the void. So we had the pin group in the shape, and now we can see that the web is maintaining itself. In addition, we can play with it. It bounces well, we can pull it right to left, and hence the interest of having mirror frame in your timeline, which allows you to test it correctly. A common problem you can face is the cache looping. To fix this, all you have to do is to switch to edit mode on any object of your scene, and this will automatically reset the cache. In order to have more control, because actually the problem is that my simulation, I can move it, but only point by point, and it's not practical to move it. So I will add a new empty, a circle, rotate it according to X, and scale it to match all the hook. If you don't cross exactly the origin of all the hook, it's not a problem. Now we select all the hook, then the new empty we just had, and we're gonna parent it with Ctrl P, then parent to object. So as you can see, if I scale it, they follow, and that's perfect, that's exactly what we want. I just noticed that we are still in web body collection, so I will move all this in the constraint collection, in which we can create a new collection that we will call secondary constraint. We are gonna move all the hook empty into this one. This new circle empty, we're gonna call it extension. You can now hide the secondary constraint collection that allow us to have a cleaner viewport. And if I launch the simulation, we can see now that I have much more control on the entire web. Do not hesitate to experiment with all the possible movements you can do. You can take a moment to play with it, that's actually my favorite part. To finalize the control of the web, because that, if you want to move it, actually you need to select everything, and that's not practical. We had a new empty, I'm gonna put a Q, that we will call web control, and I'm gonna select everything and parent it to the new empty with Ctrl P and object. Now we have an orientable and movable web, and no matter where you go, the simulation will play out the same way. You see, it works. An important point to understand is the use of the shrinking factor. For example, if I apply a parameter of -1, we will have a loosened web. But if I put a value of 1, we will have a very stretched and still web. No matter what you do, she's still because she's stretched at the maximum. And she's gonna stay still until you lower the value. This is a parameter with which you're gonna play a lot in order to get the web shape you need and you want, because it will never be perfectly what you want on the first try. We can now go to Modifier tab. Try to keep all your empty organized from 0 to your last. It will help you in case there is an error to find out which one is problematic. If at some point your simulation doesn't work properly, it's probably because the close modifier are placed on top of the hook modifier, which give us this result. It's no longer interact. When you have this kind of problem, it's easy to fix. You have to move your close modifier under the entire hook. So be sure to check the order of your modifier. We then had a subdivision surface modifier. We can put it on 2. It should not slow down the rendering of the viewport, but especially it makes the web much smoother. Then a screw modifier. This is what will allow us to add the thickness to the vertex. For now it's horrible, so we will decrease the value to 0.001. I'll duplicate it, and the second will be in X or Y. It's up to you, but the first one must be in Z. We can go up the value to see a few things. I put it on 0.01 now. What will come next will be the solidify modifier, which must be placed under the 2 screw modifier. If it's above it, it will not work correctly, as you can see. So when the solidify modifier is under the 2 screw, we can play with the thickness. With the only rim option, we get a slight difference that I like a lot, so I'm gonna keep that. Then it's up to you to manage your setting. We can also add the pin group here to refine the web on the edge to avoid having large flat angle on the end. Then we had a smooth modifier with the repeat at 30, then adjust the factor. It totally changed the shape of the web, and I will stay with this parameter of 0.131. We can see that simulation is always played without problem. If you ever feel that your web is too brittle, there are 2 solutions. You can switch to edit mode and you subdivide, but it will cause you to lose FPS. Either you can change the parameter of the subdivision surface modifier. I forgot to tell you earlier to lower the step in the 2 screw modifier. You have to put them half less, C6. It will allow you an optimal rendering in the viewport and also allow you to activate the subdivision without any issue. So, to recap, if your viewports lose in FPS, you have to reduce the step of the 2 screw modifier and change the value of the subdivision surface modifier to 1. We are now done with the shape of the web. We're now gonna move to shading. I set up a quick HDRI to get a good visibility on how light interacts with my web. I've played a lot with the material setting, so I let you copy the final parameter of the material. You can just as easily create your own if you want, but in any case, this material I propose you works very well. And now, the best part, we will add a new level of detail. We will create a new collection that I will call Web Both. In this collection, I will add a sphere that I shade smooth. I create a new texture for it. I call it Web Ball. I change the roughness to 0 and the transmission to maximum. A bit of metallic. I increase the roughness a little to make it a little cloudy, and I decrease the value of the transmission. Again, it's up to you to change the parameter and get the result you want. Now we can hide it. On the web, we had a particle system that I put to here. We check advanced and we go to 200 for now. The source will be vertices. We move to the render section, render as collection, and the collection will be webbable. I increase the randomness to the maximum and decrease the scale to 0.1. Then in children, I switch to interpolated. Be careful because by default the display is not the same as the render amount. For example, here the default setting is 100 and you will end up with a rendering that has nothing to do with the viewport and will be saturated in bold. So if your rendering in viewport satisfies you, put the same value in the render amount. I go to 20 and 20 and we will see what it looks like in rendering. I really like it, it adds a lot of detail and a very organic touch. What's great about this technique is that it doesn't slow down the viewport at all. And now we're done. The web is orientable, adjustable, and can be simulated at any time. All you have to animate is the position of this empty and this one too. For the circle, it can be the position, the rotation, and the size. And on the web itself, it will be the shrinking factor. In environment collection, I had a wall. I keyframe the position of the empty as well as the shrinking factor, and here we have our simulation of the web that stick to the wall. And from now we can play with. What I advise you to do if you want to animate the web tail is to activate the auto keyframe, launch the simulation and move your empty with G. And as you see, the keyframes are added as you go. This avoids to animate everything by hand and it gives a much more natural result. What you have to do now is click on bake and it will go relatively fast because the mesh is light. From now you can play it and we see that it's flawless. We have our simulation and if I go to rendering, this is perfect. I'm gonna give the wall a quick material. Let's talk about the advantage of this technique. Because we could have parented all the pin points to the circle, except that imagine that we are on a complex surface. I will delete my bake and we notice now that everything goes through the wall and this is not what we need. But at this time we can move through constraint collection and reactivate the secondary controller collection. I go back to the frame where I'll start my simulation. For me it's frame 5. We select them all and we put them a keyframe with I, and I want them to follow the shape of the wall at the frame 10. So it takes a little more time to adjust the positioning of each hook. When it's done, we can replay the simulation and we see that the web follows the shape of the wall. And we are done with the first method. From now I will show you a second technique that I will require more resource and will be slower in the viewport. The current problem is that the simulation will not be able to interact with another object because they are vertex and not a mesh. We must therefore apply the modifier in the same order as what I show you. And if we launch the simulation, we see that it's much slower. You can try to reduce the simulation quality to maybe increase performance. So we add a sphere with the collision modifier that I keyframe with the auto keyframe like the previous technique. The collision does not appear correctly until the simulation has been baked. Once baked, we have our web interacting. It remains quite limited, it's not perfect, but it allows us to have an interaction with all the wall and other objects. This tutorial is now finished. Consider the idea of liking and sharing as well as subscribing. The project source of the web with all the pre-made parameters are available on my Patreon. Do not hesitate to go there, it will help me a lot. I hope this helped you and you find this useful, and goodbye!